You're not going to Harvard.
Bears just pissed.
Ow!
Okay, so let's write the cosine. You guys beat me.
It all. I was just Paul.
Cosine of x. Now, I haven't practiced these. I haven't done these for a while. Yeah. Hey, wait, how many terms do I want?
I don't know.
Okay, plus. Hey, guys. Shh.
Next to the 6, over 6 from.
Study. And then it's x to the what?
X to the.
2n.
Yeah. Wait, isn't it negative 1 to the end or 2?
Yes. I was just checking my question. Let's see. And use this series to write the first three non-zero terms in the general term of the series for the function f. So what's f? It's the cosine. This bothers you, but it shouldn't bother you. It's the cosine of x minus 1 divided by x squared. So I'm going to write f of x, cosine of x minus 1, right, over x squared. So let's substitute this series in right there. Because you might have a limit that has you do that as well. I've seen that. So it's 1 minus x squared plus over 2 plus x to the 4th over 4 factorial plus, it is 2 factorial. If you prefer that, I will do that. X to the 2n over 2n factorial. And then we're going to subtract 1. And then we're going to divide by x squared.
Why do we subtract?
Because it says so.
Bye.
Okay, so what happens to the 1s?
They cancel.
And then you're going to divide every term by x squared.
So we do it minus 1/2.
So it's minus 1/2 plus,
Squared over 4 factorial.
right? Do I need another term?
No.
Was it just 2?
First or not.
I don't know. I got to go back and look at the question. Then I need another term. Write the first three non-zero terms and then the general term.
Alright.
Okay, so the next one here would be
Minus.
plus x, no, minus x to the 6th over 6 factorial.
4th over 6 factorial.
And then
Dot, dot, dot.
the hard part is the general term.
You're going to have negative 1 at the end, you know that.
It'll still be negative 1 and times x.
We have to make sure everything matches, but it's x to the what?
And x to the n.
No, you're going to subtract.
2n minus
It's
2.
when you have x to the 2n over x squared, you're going to subtract. All over 2n factorial. Now we have to make sure that if we were to write this in sigma, that this is going to work. So when n is equal to 0, do I get the first term? The question is, and I don't know the answer to this, is this going to be okay if I write, where is my n starting with this one to make this work? It's not starting at 0. I need to get at negative 1/2. So where's n starting here to get negative 1/2? Not 0, because that's positive 1. That's x to the negative 2. It's starting at 1. So my question is, will you get points if you say that this is the general term if we start at n equals 1? I don't know. If you want to be safe to get the general term, then you have to make it start at 0, because this is n equals 0 here. This is n equal to 1. So the general term, I need a negative sign, so what do I have to do with that n for starting at 0? I don't want a positive. How do I make it negative?
By putting a
N plus 1. That'll make it negative. Does it work for this one? When n equals 1, this is going to be 2. I'm going to get a positive number. Does it work for n equal 2? I should get a negative. 2 plus 1 is 3. I get a negative.
Yep.
Okay. And if I'm going to start at n equals 0, what do I have to do with this? I want to get a 1/2 there. Let me start. Yeah, n equals 0.
You're just going to have your
So it's 2n.
factorial.
Yes. But if I start with 0, this is 0. So what do I have to start with to make that 2? Plus 1 is giving me 1. I want 2. 2. Check. Does that work? That's the question, and I don't know. I'll see if I can find out before the exam on my listserv. Okay, because I never graded this kind. Does that work? N equals 1. I'm going to get 2 plus 2 is 4.
I think I would surrender my.
What about the x to the 2?
Is that only worth a point?
We're gonna, yeah, probably.
Oh.
Then this is, if we add a 2 here, what do you think you're going to do for that exponent? Add 2. That makes sense? Does that work? So n is 0, so that's x to the 0, that works for the first term. N is 1, that works. Yeah, I don't think I did what they had there. I think we need to use it later on in the problem. Well, let's just see what our points are. So 1 point for the cosine function, and 2 points for the f function, and for just the first 3 terms, and then 1 point for the general term. So it's 3 points for part A. So you can get 2 fairly easily.
Don't get that chance for your
Then you're going to get 2. Well, I think we're going to get in trouble because
later on.
Can you just do it like in physics where you say if the general term is this, then you don't get it?
we have to do the ratio test, I believe. Or do we? I don't know. I don't remember. No, must not be this one. Okay, use the Taylor series for the function about x equals 0 found in part A. Did you determine whether or not the f has a relative max, minimum, or neither at x equals 0? This is the Maclaurin series. Okay? And it says f starts with negative 1/2, which is what we have down here, isn't it? So how do I know if I have a relative max or min for this function?
Derivative.
Don't have to take the derivative. It's easier than that.
Just look at the second one.
Just look at the second term, or not second term, but look at the x term. What is the coefficient of x?
1 over 4.
No. This is x to the 0. That's x squared, x fourth. What's the coefficient of x? How many x's do you have? 0. So remember, that's f prime. Remember the Taylor polynomials? F of 0. Actually, I want t is equal to f of 0 plus f prime of 0 over 1 factorial x to the first plus f double prime of 0 x to the second over 2 factorial. So we have a candidate here. So we have a possibility of a max or min. I don't know if it's neither yet. How do I know that?
Look at your second derivative.
Look, it's the second derivative. So looking at this term, that's this one. So f double prime of 0 times x squared over 2 factorial equals x squared over 4 factorial. What will happen to the x squareds? I mean, that's the easiest way to do it. Just blindly substituting in x squareds go. Solve for f double prime of 0, which is equal to 2 factorial over 4 factorial. Clearly positive. If it's 0, we'd know nothing. And it's positive, that means my function is,
Okay, well,
it's concave up, and I would write
Apply
concave.
the second derivative test.
You have to use second derivative test, and so therefore it is a minimum. Is that all they asked me for in B? Okay. Yeah, I was just going to check the answer. I solved this equation right here for f double prime of 0. So I multiply by 2 factorial, and all I care about is the sign. Well, I want to see how many points we got. 2 points. F prime of 0 is the coefficient of x, so that's 0. And then the second derivative, they write this, and really all they do is say it's positive because it's not negative. Actually, they simplified it, but it's 1/12. It's positive, so we have a relative minimum at x equals 0. Doesn't seem like a lot of points for all that work, does it? So you get 1 point for this, and then 1 point for the fact that this is greater than 0 and your reason. So we're at 5 points, and I'd have to look at my little chart there, Isby. Yes. I did back. Where did I stay? I may not have written it down, but I talked about it. I think I wrote it down in the wrong place. I said, here's f prime of
So
0.
whenever you want to.
So let's make this complete. f prime of 0 equals 0. And whenever we want to find what?
If you ever want to find like what f prime something is, you just write out what that general term would be, and then set it equal to what you have, like Taylor polynomial, and that just solves it.
So if I wanted the 10th derivative, then I would look at the coefficient of the x to the 10th term. That's all. And I think we've got some like that coming up.
And it would be whatever the coefficient is, or do you have to take
Well, you have to get an equation like we did here. So if I wanted, what is the 10th term? It's the 10th derivative. If I wanted that at 0, then this is x to the 10th. And for this particular function, over 10 factorial, now that's the Taylor one,
Yep.
equals, and the coefficient of the 10th one would be what? X to the 10th, 12 factorial, and is that positive or negative? Well, I think it's negative, isn't it? Put it into our little general form here.
Wait, how did you know that it was going to be x to the 10th over 4?
Because I'm looking at patterns here. X to the 4th is over 6. So 8th is positive, 10th is negative. So that would be negative, and then you would solve that equation by, I would cancel out the x to the 10th. No, because this is the 10th derivative, it tells us nothing. But they could ask you for the 10th derivative. Right. So the 10th derivative at 0 over 10 factorial equals negative 1 over 12 factorial, and I'll multiply by 10 factorial, and there's your answer.
You only solve these one x.
Yes. You don't know anything about any place else. Just 0.
So they call it terms. If they say give the first three terms, that's like if these, it'd be a cosine would be 1 plus x squared over 2 factorial.
Now, if you had an x squared plus an x squared, that's still the same term because you can combine that.
Okay, but then if they want like the order,
If they want the 4th degree polynomial, you'll look for x to the 4th. So it's either number of terms, you just count how many terms there are. They have to have different exponents to count as different terms. Otherwise, they'll say give the 4th degree or the 6th degree. Your best bet, do a lot of these problems. And actually, once you start doing them, you're going to find they're not that bad. I mean, we're at 5 points already. And I'd have to go on and look at it. Okay, write the 5th degree Taylor polynomial for g. About x equals 0. They don't tell, 5th degree. See, that's different questions. So
We would just integrate what we have.
g is 1 plus 0 to the x of f of t. I'm going to write that down now.
Now, may I interrupt?
Oopsie. Yes. G of x is 1 plus the integral from where? 0 to x of f of t dt. So it's 1 plus the integral from 0 to 1, and now I got to go back and find that one. This is the problem with doing it like this, because I can't ever remember where it is. And it looks like it's this one right here, right? And I want the 5th degree. So I am going to take a picture, maybe. Oh, it doesn't look pretty. It's going to look like that. And we'll copy it. Yeah, this thing needs to be fixed and paste.
And we only use 3 terms, right?
You just want to get the 5th degree, so it's not a big deal, right?
Yep.
So it's 1 plus, and the integral of negative 1/2 is negative 1/2 x. Integral of this is plus x cubed over 3 times 4 factorial. And the integral of this is minus x to the 5th over 6 factorial times 5. And if you don't get what you're looking for, then you're either interpreting it wrong, it's the 5th degree polynomial, or you might be thinking 5 terms. So make sure you check that. And it asks for the 5th degree polynomial, because they're not going to make a mistake. And we have to evaluate that at 0 and 1. What's going to happen at 0? I like that. So it's 1 minus 1/2 plus 1 over 3 times 4 factorial minus 1 over 5 times 6 factorial.
yeah, where'd you get the 1 from?
No, they just said that, I think,
It's 1 plus that. They wanted G, didn't they?
no, the integral evaluation material. Why do you have to evaluate?
Oh, so, why did I make that 1? It's X, isn't it? I just copied it wrong. So the answer's there.
It is X.
Yeah. So my answer is there. I just,
It's gonna give you a function.
that's what I thought, but I bet we're going to do something with that G of X in a second, so I probably shouldn't have erased it. Okay, let's see how many points that is. I bet that's only 2. Because we're at 5, maybe 2, that gives us 7, wouldn't it?
So the,
There it is. We even get 2? Yeah. 2 correct terms and all the rest of them. So if you get the 1 minus X over 2, you've got it.
Why is it
Oops.
why is it 1 minus?
This is G of 0?
This is G of X. I integrated to 1, I don't know why.
What's the difference between correct terms and mean terms?
So if you get 2 of these correct and you mess this one up, you still get a point. Like I said, I haven't graded this. So I'm not that, I don't know so much, but if I haven't made any mistakes, I got 7 points right now. It wasn't that bad.
Just go on.
Yeah. And the last one, I think, is an error. Okay, we have an alternating series if we evaluate it at 1. And they decrease in absolute value to 0. These are the conditions for the alternating series test. Use the third degree Taylor polynomial for G to estimate the value of G of 1. Then explain why this estimate differs from the actual value by less than 1 over 6 factorial. This is the error. They're saying that when you find this G of 1 minus the actual value is going to be less than 1 over 6 factorial. And how many terms am I going to use? It says the third degree Taylor polynomial. So I'm going to go over here.
The fourth.
I will. Why do you want me to go back? Oh. So you evaluate G, only the third degree at 1, but I'll use the fourth one to find my error. So you always kind of hope it's, the Lagrange is exactly the same thing, except you're looking for a maximum value and you have to evaluate your derivative at that value and the x at that value, wherever you're doing it. So it's a little trickier. So what's G of 1? Do you have to add these? No. Plus 1 over 3 times 4 factorial. That's it. That's the third degree, right? Okay, and then, and hopefully I would have evaluated that, and then my error should be less than this. So it's 1 over 6 factorial times 5. That's got to be what, less than 1/6? Or is it 1/6 factorial?
Still is.
Well, sure, that's smaller, right? And I would write alternating series estimation theorem. Go through that PowerPoint that talks about what graders want to see. It doesn't matter if you're A, B, or BC, it's the same thing. They want to know if you know the math.
This is Lagrange, we believe, which are alternating series.
This is alternating series test, but the Lagrange is exactly the same thing. It's the same term, but you have to maximize your derivative. You want the derivative at the biggest one. Look at yesterday's video. Oh, they took the derivative. This is the upper limit when you do the derivative right here on the Lagrange. So you want the maximum value. So if it were a sine function, what's the maximum value you can have for a derivative? It's 1, yeah. So they don't try to make it hard. And obviously that's 1/5 of 1 over 6 factorial, which is less than 1 over 6 factorial. So what do they want to see here? Or is it here? No. 2 points. And you're okay with this. So don't waste your time simplifying that. At least that's the way I interpret it. Look at the PowerPoint, that's what he says too. Since the Taylor series evaluated is an alternating and the series terms decrease, alternating estimation theorem should work too. That we know this. This was an easy one. We should get all 9 points on this.
Are they all like that?
Have you not done any? Well, I give you 15 minutes
Alternating series.
to try one of these problems on your own, and I have the answers there.
What's the definition of the alternating series estimation?
The alternating series has to be its summation of -1 to the n, b sub n, and B sub n has to decrease. And the limit of B sub n, as n goes to infinity, has to be 0. And it has to alternate. But you know, I always have to have that limit of the sequence be 0, no matter if it's positive or negative.
Then what can we do with those three cases?
Then you can use the alternating series test. You just have to say it, alternating series estimation theorem. That's it.
Can I have that? No, I need that.
So,